So I believe by now on one side, you should be able to see my screen. You should be able to see the lesson notes, which is the measures of variability / dispersion part 2. By the way, this lesson note is already in your Google Drive. You can download it and then make benefit out of it. And on the other hand, you can see the blackboard where I'm just writing EDUC 801. All right. So today, which is the 7th of August, 2024, we proceed with the continuation of measures of dispersion, which is on Z-square. So what do you mean by Z-score? What do you mean by Z-score? To have a feel of how Z-score operates, let me start with a simple tweak. All right. Suppose you have a friend who perhaps is under department within the Faculty of Education and took a course, maybe a psychology course, like for instance, EDUC 803, as the case may be. And then the student, your friend, came to you and told you that, hey, you know what? I scored 95 in the course. The exam, the cumulative score in my exam was 95. What comes to your mind? You can unmute yourself. Let us have a bit of interaction before we proceed here. You can unmute yourself. When your friend comes to you and tells you that he scored 95 in an exam, what comes to your mind? A good score or a bad score? Please unmute yourself and speak.
A good score.
Is it a good score?
A good score.
Okay. A good score. Perfect.
It's a good.
So
it's a very.
95, you think yes, it's a good score.
Yes.
It's a very good one. Perfect. Good. 5 is over 200. How do you feel after that?
It's below average.
It tells you that the 95 score is over 200. Do you still think 95 is a good score?
No, it's not.
It's not to average.
Sir.
Now it seems like it's not up to C, which is fail for postgraduate student. Okay, but what if it comes back and say, you see, in that course, the highest mark was 105. So will you consider your decision again?
Yeah, he tried. It's better.
He tried. He tried, right?
Good
Okay.
attempt.
Like, yeah, it's a good attempt. We feel like maybe perhaps the course was so difficult, and then he got 95. And again, he comes back to say that the lowest mark is actually 95. What do you feel afterward? The lowest mark is 95 and the average is 102. What do you feel after that?
Well, it's still a
Should have done better.
well, should have good point.
So your friend actually was the lowest scorer in that particular course and is scored below average, where the average was 102. Yeah, so maybe not so good. Yes, sorry, brother. We tell him, oh, sorry, you need to do better next time. You actually fail the course. What I want to bring out from this simple off and on is the fact that you see, a single score, you cannot accurately make a decision on a single score until you look at the surrounding scores or you compare the score with the distribution of other scores in that particular test or exam. So that statistic that we now put a score in a standard way such that you can easily compare it with the distribution of the data set is what we call Z-score. All right? So Z-score will help you to make a decision on a score in relative to the other scores in that particular distribution or in that particular data set. So it modifies an individual score so that it conveys the scores relationship to both the mean and the standard deviation of its fellow scores. And it is so easy to compute or to calculate Z-score. To calculate Z-score for any individual score, you just need to use very simple arithmetic. Z equals to x bar. I want to believe x minus x bar is not something new to you. We have done this several times. This is deviation. We did it from deviation, from variance, standard deviation. We usually talk about the first column after we compute the mean, x minus x bar. So Z is x minus x bar, that is mean deviation or deviation from the mean, divided by the standard deviation. Can you see this? So the formula for computing the Z-score is Z equals to x minus x bar divided by the standard deviation. X is the individual score of the data set. X bar is the mean of the data set. Then S is the standard deviation. Is it okay? X bar mean, sample mean, S sample standard deviation. Okay, so this is so pretty easy. And then we can always come back to this formula and use it to make a big deal. It is so cheap and easy. Deviation divided by what? Standard deviation for each individual score. Okay, how do we now interpret Z-scores? This is the next subtopic. How do we interpret the what? The Z-score. Z-score is interpreted in relation to the mean or relative to the mean, as we can see, is x minus x bar.
Yes.
So nobody should tell us that Z-score must be related to the mean and it must be related to the standard deviation. So a Z of 0 indicates the value is exactly the mean. You see, x minus x bar. If it is equal to 0, that means your friend actually scored the mean. If the mean is 50 and it scored 50, so 50 minus 50 is going to be 0. Whatever
Yes.
the standard deviation could be. So far that you have a 0 here, and of course, standard deviation cannot be 0.
Yes.
I'm not sure if we made this remark when we are talking about standard deviation. Standard deviation cannot be 0. That means there is no variance. If standard deviation is 0, there is no variance.
Yes.
So standard deviation cannot be 0. F is different from 0. S cannot be what? Cannot be 0. Otherwise, there is no individual difference. Everybody got the same score. So if x minus x bar is 0, definitely standard deviation cannot be 0 and 0 0. So the only time that I mean a positive Z, remember standard deviation is the square root of variance. Standard deviation is what? The square root of variance, and variance is always positive. So therefore, standard deviation is always greater than or equal to 0. There is no negative standard deviation. So if there is no negative standard deviation, that means the only time this Z is going to be positive is when x minus x bar is greater than 0.
Yes.
That is, x minus x bar is positive. And that means your friend's score is greater than the mean. Your friend's score is greater than what? Than the mean. That is why if Z is positive, it indicates that that score of your friend is greater than the than the mean.
It's
Is
positive.
it okay, everybody?
Yes, sir.
Yeah. A positive z-score indicates the value is above the mean. What about a negative z-score? Again, S is always positive. So Z, which is a x minus x bar, Z is less than 0 if and only if x minus x bar is less than 0. Okay, so this says a negative z-score indicates that your friend has a score that is less than x bar, less than the mean. So this is the first point of interpretation. If the z-score is 0, that means the individual score is actually the mean. If the above the is greater than the mean, and if z-score is negative, it means that the score is below the mean. Take note. Perfect. What about magnitude? How big is z-score? The magnitude of the z-score indicates how far away the value is from the mean in terms of the standard deviation. So if z-score is what? Is 2. It means that the individual score is 2 above the mean, is 2 standard deviation above the mean. This implies individual score is what? Is 2 standard deviation above the what?
The mean.
Above the mean. Okay? Is 2 standard deviation above the mean. All right? So what does this? Now remember, your Z is x minus x bar divided by s. So what is this one telling you? If Z equals to 2, it means x minus s bar divided by s equals to 2. And that means x minus x bar equals to what? 2x. Can you see 2 times x? So it means that this individual score is a 2 standard deviation above the greater than the mean. Look, this is x equals to x bar plus what? Plus 2s. And this means again that what this individual score used to be greater than the mean is what? 2 standard deviation. So the magnitude of z square is telling you how much the individual score is standard deviation above the mean. So again, if z is now minus 2, if z score is minus 2, it means the individual score is 2 standard deviation below the mean. You see that? Is what? 2 standard deviation below the mean. If it is positive, above the mean. If it is negative, below the mean. Do you see how we link 1 and 2 together? Magnitude and relative position to the mean. So if Z is 1.8, it means the individual score is 1.8 standard deviation above the mean. And what if Z is minus is what? 1.2 standard deviation below the mean. Excellent. So this interpretation is very important. Thank you. Now, what about comparative analysis? In the interpretation of Z square, we can use it for comparative analysis. We can use it to compare individual scores from one test to another, or from one subject to another, or from one course to another, or from one locality, one state, wherever. You can always use Z score to make comparison across groups. Okay, let us look at this example we have in here. This is actually coming from a test, right? I think I wrote it there. Let us check out the following Z-score of selected students on 2 100-point tests in a general psychology course. So we have a table given to us. All right, now we are going to analyze this table together. All right. I want to believe you can see clearly what is on the table. You can unmute yourself and answer if you can see it clearly. It is clear, right?
No, we cannot see.
Yes.
It's not clear.
Some of you cannot
It's
see.
clear,
Okay.
sir.
So we can have it this way. For some,
Okay,
maybe it has to do with yeah, it is clear actually. And maybe it has to do with the phone or the electronic gadget you are using. So
size.
all
Very
right.
clear.
It's clear.
Yeah, it's very clear actually. So
Yeah,
let's
it's very clear.
okay. We have students. Okay. And then we have them Chris, Robin, Marty, and then we have Terry. Okay. I want you to look at something. In test one, Chris scored 76.
Yes.
With Z score of plus 2.20. This is test one. And in test two,
Robin.
score 76. But now 7 in the first test, Robin scored 54 with Z score of 0.00. While in the second test, he scored 86 with Z score again of 0.00. While for Marty, she scored 58 in the first test with Z score of 0.40. Okay. While in the second test, she scored 82 with Z score of minus 0.67. Okay.
Yes, sir.
While the last person, Terry, scored 58 with a Z score of
Plus
0.40. In the second test, he scored 90 with a Z score of 0.67. Now, good. Let us now analyze the relative performance of each of these students.
Okay.
Look at Chris using Z score. Look at Chris in the first test. He scored 76. In the second test, again, he scored 76. Look. Now, decorum, please. If we compare only the raw scores, we can see he scored 76, and again, he's in the first test, and then 77. It didn't go down. It just remained the same. Is that correct? That would have been our interpretation. But when we now compare his scores with to identify the problem, look at it. In the first test, where he scored 76, can you just move yourself that person? In the third square is 2.2 positive. That means it is a 2.2 standard deviation above the mean. That is a very high performance. That is what? A very high performance. But when you look at the second test, where is scored 76, but look at the Z score. The Z score is minus 1.67. That means 1.67 standard deviation below the mean. Can you see it now? In the first test, it's called the IS. In the second test, it's called the same thing, but that IS now is now the lowest.
The lowest.
Because it's having minus 1.67 standard deviation below the mean. So Chris actually performed poorly in the second test. He performed extremely poor in the second test.
Mhm.
Do you understand this?
Yes, sir.
Yes, sir.
Okay, let's go to Robin. Robin in the first test got 54 and Z score of 0.00. We said if Z score is 0, it means he scored the mean. Is that correct?
Yes.
That means Robin actually scored the mean in the first test. But when you go to the second test, he scored 86.
86.
Me
The same
looking
thing.
at 54 and 86, you say 86 is bigger than 54 now.
Yes,
That
sir.
means
Yeah.
he performed very well. Is it
Oh,
not?
with the same. Yes, sir.
In the first test, he got 54. In the second test, he got 86.
6.
Mere looking at the raw scores, you will say, oh, Robin has performed better. But your
The second
interpretation
test.
is wrong. 0.00. That means he scored the mean. In the second test again, the Z score did not appreciate and did not
Please,
differentiate.
Admin, make una mute everybody.
It
Now.
was only
That your network is also breaking.
it was only maybe from your end. In your in the two tests, he has scored the mean. Are you okay with this? Our moderator should be in action. Mute everybody mutable except the speaker. Okay, so you can see now how wrong you can be if you base your interpretation on raw scores. You need Z score. Okay, let's go to Marty. Marty scored 58 in the first test, which was above the mean, 0.4 standard deviation above the mean. In the second test, Marty scored 82, which is far higher than the score in the first test. But unfortunately, look at the Z score. It's minus 0.67. That means it is 0.67 standard deviation below the mean. Below the mean. They actually failed this second test with a high score and passed the first test with what? With a B.
The low score.
Okay, let's go to Terry. Terry scored 58 in the first test, which was 0.40 above the mean. But in the second test, he scored 90. Again, which is what? 0.67
Above the mean.
So, what about the application of Z scores in education? We have quite a number of applications. Now, I just mentioned the issue of relative grading. Moderator, do your job. I just mentioned the issue of relative grading. Okay. Now we can use it for so many things. Standardized testing. So we can use Z score to compare student performance across. Okay. To compare student performance across different tests and assessments. I want to believe you are seeing my screen, right?
Yes, sir.
Okay, perfect.
Yes, sir.
So, for example, let us take example 1 for today. Let us say a student scored 1,400 on the SAT. You know, SAT is an exam, international exam. So I think for those in accounting or thereabout, the SAT score is 1,050 with a standard deviation of 200. Okay, a student scored 1,400, and the mean of SAT is 1,050 with a standard deviation of 200. So we want to calculate the Z score. The Z score for the student, remember, the student score, that is X, is a 1,400. And the mean X bar is a 1,050. The standard deviation is what? 200. What is now the Z score for that student? The Z score, according to the formula, is X minus X bar divided by S. X is 1,400 minus 1,050 divided by 200. Is it correct? So this is 350 divided by 200. So what do you get? What is 350 divided by 200? Tell me. What is 1 point what? 1.75. Thank you. So the Z score is what? 1.75. That means the students are above the mean. Perfect. Now, suppose the student in accounting ACT scored 30. ACT. The student scored 30.
Please, you are too fast, sir. We're not assimilating.
So in ACT, the student scored 30, and a deviation of 5. In ACT, the student scored 30. That is X equals to 30. And the mean is 21. X bar is 21. Standard deviation is what? Is 5. What is the Z score? The Z score is going to be by the formula X minus X bar divided by S, right? 30 minus 21 divided by S. And our S is what? Is 5. Okay, let me take the eraser out. Divided by 5. So this is just what? 9 divided by 5. And 9 divided by 5 is what? 1.8. So the Z score is what? Is 1.8. Now, let us look at something. In accounting, where is scored 30, the Z score is what? 1.8. But in SAT, where is scored 1,400, the Z score is what? 1.75. Okay, in these two subjects now, which one of them that the student perform better?
In art.
Wait, in art it's called 30, while in SAT it's called 1,400. How on earth can you now say he did better in art?
The Z score of art is greater than the one on in SAT.
Thank you. So this is where we are driving at. We look at the Z score, not the individual score. The individual score can be misleading. The test can be easy or difficult. But individual score will not tell us that. But by the time we convert everything to Z score, we can now make our comparison fluently.
Yeah.
Thank you. Comparing test scores in different subjects. This is more or less like what we have done. Now we can also use Z score to identify high performers. High performers, so that you can get for them, maybe take them to gifted school. You know, we have a school in Nigeria that is gifted. It's only for gifted children. So they are able to pass it, then they are qualified to be in that school. Otherwise, they reject the application.
Excuse me, sir.
To identify
morning, sir.
outliers, very extremely high score. Let us take a look at this. A student. Good morning, ma'am. Go ahead. You have a comment?
The figures in the first one, we did not get it right. Is it 050 or 1050?
1050, ma'am. 1050. Look at it.
Okay, and then
1050.
the S. Okay.
The S is standard deviation, and it is 200. Look at it here.
And this one is okay. This one is 1050, ba?
Yeah, 1050.
Okay, thank you.
Are you fine?
Yes.
Okay, now let's go to example 3. A student scored 95 in a science test, where the mean is 70 and the standard deviation is 10. What can you say about the score of the student, Z score? Again, we write it. Example 3. A student scored what? 95. X is 95. Then X bar is what? 70. And the standard deviation is what? It's 10. Okay? So what can you now say about the Z score? By the formula, Z score is X minus X bar divided by S. And this gives 95 minus 70 divided by 10. Moderator, do your job. So 95 minus 70 divided by 10. So this will give us what? 25 divided by 10. And that is what? 2.5. So the Z score is what? Is 2.5. What is the interpretation of this? That means the student score 2.5 standard deviation above the mean. 2.5, not even 1. 2.5 standard deviation above the mean. So this is a very extreme or very high score in the test. Okay? What if the other way around? Let's see in example 4. You want to identify low performer in the test. Example 4. It says a student scores 45 on the same science test. That same science test, a student scores what? 45. That is X equals to 45. Remember, the mean is 70 and the standard deviation is 10. What is the Z score of this person? Z score
minus 2.5.
Thank you. Is going to be 45 minus 70 divided by 10. Minus what? 25, right? Divided by 10. This is what? Minus 2.5. So this interpretation of this, it means the student score 2.5 standard deviation below the mean. 2.5 standard deviation below the mean. Perfect. Okay. Can you mute yourself? The person that is the breeze from the side is disturbing us. I'm waiting for you to mute yourself before I proceed. Okay, thank you. So, placements in gifted programs. This is another example where you can identify outliers. And then you can use it again to the very low score like this. It needs remedial. You need a remedial program. You need to give him extra coaching. All right. So we can also use it for evaluating effectiveness of a program, whether a program is effective or not. Or you can use it for placement decisions. Okay? This is when you use to dictate somebody with very high score so that you can put him in a gifted school, and somebody with a very low score so that you can put him in a special school. A lot of examples we can walk through. Maybe on Friday when we get to our tutorial questions, we'll solve more problems. So Z score, as you see them, there are some limitations to z-scores. All right. So these limitations, we want to go through them before we go to the second section of our lesson. Number one thing is the fact that z-score relies on the assumption of a normal distribution. And this is coming from the standard deviation and the mean, because you are normalizing the scores. Z-score actually normalizes this. And a normal distribution, as we have it in here, Z-score that is one standard deviation above the mean. Z-score that is what? One standard deviation above the mean. One standard deviation above the mean actually covers 68% of the area under this graph. This is what? 1SD. One standard deviation above the mean. Then two standard deviation above the mean. Two standard deviation above the mean, that covers a bigger space, and it covers 95%. 95 what? Percent. This is for two standard deviation above the mean. Then we also have three standard deviation above the mean. Three standard deviation above the mean. So this covers 99.1, if I'm not mistaken, or 99.7%. This is for what? Three standard deviation above the mean. So where I've digressed a little bit is the fact that Z-score actually normalizes your data, or it relies on the assumption of what? Of normality. However, the areas under each of these normal distribution, it actually tells a bit about one standard deviation, two standard deviations, and three standard deviation. Okay, then it's a relative measure. Z-score are relative and do not provide absolute performance metrics. It's relative to the scores in that particular distribution. Impact of effect size. Yes, if the effect size is small or big, this can also affect the Z-score. It will affect your standard deviation, which will affect your Z-score. It will affect your mean, which will affect your Z-score. And there's also misinterpretation. You can misinterpret your Z-score at times. So you need to be very careful when you are interpreting it. Then presence of outliers. Remember, outliers we it will affect your standard deviation and big bar over S. Anything that affects the X bar is going to affect the what? The Z-score. So outlier with bias, in that case, your Z-score is going to be biased. So take note of that. Box plot. Box plot is a plot. That is, you should expect a graph. That is just the meaning. You should expect what? A graph. But this graph is not an ordinary graph. It tells a lot about descriptive statistics. And in fact, it combines a lot of descriptive statistics in just one figure. Number one, in just one figure, box plot will give you two measures of central tendency. Number one, box plot will tell you the mean. Immediately, you see it. Number two, box plot will tell you the median. Remember, mean and median, they are measures of central tendency. Again, immediately you see box plot, it will tell you about two measures of variability, two measures of dispersion, which are the range and the interquartile range. And by extension, this you can see the interquartile range immediately. You can know the Q1, the first quartile, third quartile, the third quartile, and the first quartile. Try this. Box plot will tell me about the mean. Box plot will tell me about what?
Yeah.
The median. Immediately I see it. Thank you. 2 measures of central tendency. And if you tell me about the interquartile range, for telling me about interquartile range, I can know Q1, I can know Q3. Q1 is your first quartile, or you call it 25 percentile. 25 what? Percentile. And Q3 is your third quartile, or you call it 75 percentile. Are we together? Again, box plot will now also tell me information about skewness. Whether your data set is positively skewed or negatively skewed. Hey, look at all these things together in one plot. Hey, so interesting. All these things together in just one plot. This is the power of what? Of box plots. Okay, let us pick the first example and identify these things. Look, this is a box plot. I have labeled them for you so that it will be easier to get. Mere looking at the box plots, yeah, what do we see? We can see a point inside this box. That point inside the box, it tells you about your mean. I repeat, the point inside the box tells you about your what? Your mean. I'm making this bigger now. This point inside the box. So for this particular distribution, the mean is around 18. It's close to 20. The horizontal line that you see inside the block, inside the box, that is your median. The median is the horizontal line you see in the box. And that is around 19 in this particular distribution. Since you know the minimum and the maximum, the range is just maximum minus minimum. You know the range. Box below here, it gives you Q1. And above here, it gives you Q3. And since you know Q1 and Q3, interquartile range is Q3 minus Q3 minus Q1. Immediately you can know it. What if the mean, as in the case of this particular distribution, the mean is below the median? That means the mean is less than the median. If the mean is less than the median in any distribution, it means the particular distribution is negatively skewed. I write this. If the mean is less than the median, okay, then the distribution, thank you, the distribution is negatively what? Skewed. Okay? Otherwise,
the man is a good.
Otherwise, it is positively. Otherwise, it is what? Positively skewed. If the mean is below the median in a distribution, that distribution is negatively skewed. If it is above the median, it is positively skewed. If it is the same as the median, it is symmetric. If it's equal to the median, it is what? Symmetric. It is symmetric.
It's a normal distribution.
Yeah.
Yes, symmetric.
And again, one thing we can also know from here, you see these whiskers. The length of these whiskers, they are telling you information about skewness. If one is longer than the other, then that distribution is skewed. If the lower whisker is longer than the upper whisker, it is negatively skewed. If the upper whisker is longer than the lower whisker, it is positively skewed. Only this picture, we can come about so many things. Interesting. So this is the power of what? of box plots. Okay?
Okay. This is box plot for 4 distribution.
What I've just explained by mouth, you will find them in this notes, including the technique to know symmetric. Okay? And again, something I didn't mention. Box plots can also tell you about outliers. Outliers. You can see as we have this thing here. If we can get about the extreme values in the particular data set, which we call the outliers. But in this particular distribution, we show here there is no outlier. That's why there is no asterisk anywhere. But if there is outlier, box plot. Perfect. Let us speak our last example for today on the box plot. I want to believe you can all see this box plot clearly. The very first thing you will see here is the fact that the box plot that is vertical here, look at it, is standing vertically here. Now it is what? Horizontal. Can you see?
Yeah. Yeah.
It is the same. Whether it is vertical or horizontal, it is the same. You just need to make some changes in the way you understand it. Instead, or you can turn it. You can turn your book. If you like, you can turn your book. Or you can turn the screen and make it vertical so that you understand the vertical very well. But the way you can present a box plot, you can present it horizontally or you present it vertically. They will still convey the same information. Okay? Now we are given these 4 box plots about 4 different distributions, A, B, C, and D. Now we have to answer some questions. And these questions will form our examples for today. Let's see the very first question. 1. Are we okay, everybody? Good.
Okay, can we the charbonnet? No, I want biscuit. You get biscuit.
Madam.
Our moderator, please. Biscuit there. Okay, we are doing something more serious, yes, than biscuit here. You can see, I can see some people, they are very attentive, looking for how this thing will end. Yeah. We are given these 4 distributions. Now, which distribution has the greatest skew? Okay,
D.
you agree that number 1 is what?
Number 1 is D.
Number 1 is D.
Number 1 is D.
It's D.
D for dog.
Yes, sir.
Yes, D for dog.
Number 1, D for dog. Let us analyze it first and foremost.
It's
You
B.
see, let's analyze together. You see, for we to talk about skewness, we need to look at the dot, the location of the dot in relation with the line. The middle line now that you see in the box, that is your median.
That's the median. Yes, sir.
Look at A. The dot is after the median. That is,
After
the
the
dot
median.
is higher than the median. That is positive skewness. It's positive.
Skewness.
Yes.
But when you look at B now,
B is the one that's the answer.
B for boy, the dot is before the median. That one is negative skew.
Skew.
When you look at C, again in C, the dot is below the what? The median.
The median.
It's also negatively skewed.
That one is also negative D.
Skew.
You find that the dot is after the
median.
After the what?
The median.
Yes.
The median.
Positively skewed.
The median. That one is also positive skew,
Possibly
right?
skewed.
So we have 2
Yes, sir.
positive skew, A and D.
And
We
yes.
have A and D. Now the question is, the question is, which one of them is greatest positive skew? People say D for dog. How do you know? How do you know? you know, the answer is between A and D now.
D.
The answer is between A and D.
D.
Okay. So
The
how do you
answer
know
is
that
A,
the answer
sir.
is D? Why?
Because
The answer is A.
Because of the
the,
spacing.
the distance between the median and the mean
And
is
the mean
more
in D is wider.
compared to A.
No, sir. The answer is A.
Okay. Why?
Now, the reason is the score
Why the
of
answer is A?
mean. Now, the reason is that the score of mean of D is range between 42. What that's mean? The score mean of A, it range between 49 to 50.
Okay.
Yeah, but
That
to
is
me,
one
it's
way.
D.
So why is your own D? Because
the median and the mean, the distance between them is more than the distance between median and mean in A.
okay.
Oh.
Yes. This tells you something again about, so we're having A and D as option, but the right answer is actually D.
Yeah.
Why? Because the mean is greater than the median, and the high score whisker is longer than the low score whisker. Okay, look at the length.
Yes,
in A, they are almost like the same.
The same.
Look at the length of the whisker. In A, they are almost like the same length. But
Yes.
in D, the upper whisker is far longer than what? That the whisker, the length of the whisker also tells you the length of the whisker also tells you about the skewness. If the lower is longer than the upper is negatively skewed. So it is this length now that you compare that will allow us to judge. And that means, because at times box plot may not have the mean. It is not every time that box plot will have the mean. So you look at the whiskers to know whether it is positively skewed or negatively skewed. So the right answer here is what? Is D. Okay, thank you. Yeah, which distribution is the most compact? Most compact. Most compact has to do with smallest IQR, smallest interquartile range. It has to do with the length of the box. How big is the box? Or how long is the box? The one with the smallest box is the most compact data set. You know what that means? Remember IQR, it covers 50% of the data set.
Yes.
Remember?
Yes, sir.
So now look at these distributions very well now. Which of them is the most compact?
C.
The answer is C. It is glaring. You can see most of the data sets, they cluster together. And even look at the minimum and the maximum value. They are very close. The minimum is around 70. I mean, the maximum is around 70, and the minimum is around 50. So you can see the box is very compact. Take note.
Yeah.
Which distribution has a mean closest to 40? This is the easiest question.
Which number is this one?
D.
Number 3.
D.
Which distribution has a mean closest to 40?
D.
D.
The answer is D. Yes, because the mean is this dot.
D.
Yes.
But is D.
Yeah, thank you. So number 3 is what? Is D.
It's D.
So number 4, which distribution is most symmetrical?
C.
C.
A.
Is the most compact, but most symmetrical.
The most compact is likely the most symmetrical. It's likely. Okay.
What is the
But
meaning of
unfortunately,
symmetrical, sir?
the answer is
C.
not true here.
A. Okay, no. So if I
Symmetric. Remember, symmetric means identical in shape. The one on this side is identical to the one here. Symmetric.
Okay.
I just mentioned that the most symmetrical is likely to be the most compact, but it is not true all the time. And in this case, it is not true. and why?
It's A.
Because A is
It's
A.
A.
It's A, sir.
A looks so. If you look at why it cannot be C, C is almost, but C is negatively skewed.
Yes.
With a very long lower whisker than the upper whisker. So that one cannot be symmetrical. You see it now. But when you look at A, though A is positively skewed, right?
Yes.
However, the length of the whiskers, they are almost the same. You see, the length of the whiskers, they are almost the same. Yeah. So that means it is symmetrical. Unlike B, the lower is longer, far longer than the upper. Unlike D, the upper is far longer than the lower. So the distribution that is symmetrical, most symmetrical, is actually what? It's actually A. So the answer is A.
I got
it. Number 5. Which distribution has a median closest to 50?
B.
B. B.
B.
Closest to 50.
B.
It's A.
It's A now.
B. A. A.
It's A, pa.
Closest to 50.
Closest to 50.
It's A.
B.
As what? Wait. What does it mean or median?
Put your ruler.
Okay, it's A. Both of them, either mean or median, both of them is
median.
No, I disagree with you. Look at it very well.
B. B is the answer.
B. Median closest to 50 size. B.
Yes, median closest to 50.
Yes, sir.
Median is this middle line in the
It's
box.
B.
It's B now.
Yes.
Look at A is far
Yes, it's
behind.
B, sir.
Yeah. So the answer is what? Thank you. Are we okay now? Number 6.
Number 6 is B.
Which distribution is most the longest
negatively skewed.
lower whisker?
Whiskers was
Is B.
C.
That's what?
C.
Hi.
Longest lower whisker.
Is A.
Is B.
This one is B.
Remember, A is positively skewed.
Yes, B is negatively
A is positively skewed.
Yes, sir.
Yo, wow. So the answer is what? Is B.
Is B.
Okay?
B. Yes, it's B.
Thank you.
The answer is
The last question, question 7. Which distribution has the largest range? Largest range.
A is A.
Is A. A is A.
Yeah,
Yes,
the box
it covers almost everywhere.
The box is
Is A.
yes.
So it is A. Are we okay with